By the way, from geometric point of view, we looked at special curves, line and the circle, and we kind of simulated an arbitrary motion, or rather an arbitrary curve, by a line and a circle. Now in 3D, circle is always flat. Now what would be the next curve, geometrically, that approximates any curve even better than any circle?
Sphere.
Is that a curve? Is a sphere a curve? Is a particle moving along a sphere? Well, a curve is a curve, you know. It cannot be surface like a sphere. So you're somewhat right about the sphere, but there should be something about being a curve. So what is the next level complexity of a curve? Like the third degree.
Ellipse or third degree.
Ellipse is always in a plane, right? So, well, you know the Kepler's law, probably. The first law of Kepler says that all the planets follow ellipses as they rotate around the sun, and all these ellipses are in one plane. So, the ellipse for Earth may be different from the ellipse for Mars, and even the planes may be different. But for the Earth, the ellipse stays in one plane all the time. And now I'm really interested in three-dimensional curve, like a spiral. So, how to approximate three-dimensional curve by something beautiful and really three-dimensional? So you really have to think about an example of a curve that is three-dimensional, but it is so nice.
Could you do it with the change in angle of the oscillating planes as it moves along?
So what will be the curve? What will be the motion? You see all these curves all the time. Well, I mean, you've seen them a lot. Well, think about three-dimensional curves during the weekend. Observe them around you and choose the most beautiful, the most all kind of consistent, right? Because line is very consistent, having the same direction all the time. The circle is always consistent, having the same curvature all the time. And now you're looking for something else, which is consistent in many different ways, but it's really 3D curve.
I think of a charged particle moving in a magnetic field where the force exerts it in one direction, but it has constant velocity and acceleration. So top down looks like a circle, but if you were to look at it from inside, it is a spiral.
Have you seen a spiral? Aside from magnetic field and a charged particle moving in that?
Slinky. Slinky.
What is that?
It's like a metal coil toy that goes
Oh, I see.
downstairs.
Okay, all right. Isn't that a beautiful, consistent curve? Have you ever screwed something with a screwdriver? And that stuff, it's the same thing, making the spiral. And every time you make a turn, it goes in by exactly the same amount of. Right? So, yeah, those are the curves. So the next level of approximation is to approximate a three-dimensional curve with a spiral, and really to see what's beyond curvature in the spiral, because spiral has a curvature, but it has also something else.